Hey there, IT 145 students. So in this recording, we're going to go through decision structures in Java. So decisions are used in code to make choices. So that way we can handle all sorts of different cases of things. So the first section is just going to introduce the idea of making choices. So let's kind of scroll down here, and they have a flowchart here where they're going to get a user's age. And what we want to do is figure out what their hotel rate should be. So it starts out, the hotel rate's 155. We get their user age, and you can check to see that they have a decision right here. They're going to check if the user age is greater than 65. So remember, in a flow chart, you always have two paths. So the true path, that means their age is greater than 65. Well, they get a $20 discount. Otherwise, if it's false, then we just continue on. We don't get a discount of any kind. So real simple example, if your age is greater than 65, then you get the discount. Here's a case where we're going to handle um, two cases. So they're going to get a user age. They're going to check if it's less than 25. So if it's less than 25, then their insure price, so I'm assuming this is for their insurance, is $4,800. If it's false, that means their age is not less than 25. That means they are greater than 25 or equal to 25. Keep in mind that this doesn't include the equals. So the false branch down here, this is you are 25 or older, so you get an insurance price of 2,200. So this is a case where we have two branches, two paths that are actually performing some kind of work. Before, we really only had one branch do anything, but here we actually check and we have two different branches that result in two different prices. And continuing on, we could have multiple decisions that we need to make. So here we're going to get the number of years. We're going to check if the number of years is 1. And if that's the case, then they are newlyweds. Otherwise, we're going to continue on. If the number of years is 25, then that's the silver anniversary. If that was not true, then we'll check if the number of years is 50. And if that's the case, then that's the golden anniversary. And otherwise, if we don't have any of these true cases, we end up with just a simple congrats. They don't get any kind of special notation there. Okay. So again, introduce you to the idea of decisions here. How you structure the logic is going to depend completely on the problem that you are solving. One thing that I can't stress enough, though, is make sure you understand when to use the less than, when to use less than or equal to. Keep in mind edge cases. Make sure that you are able to go through and test each kind of case as it is needed. So let's go to the next section. So here we'll actually introduce the syntax in Java to write an if statement. So we're going to come right down here. And so in Java, we have the if keyword. You have to use open and closed parentheses surrounding whatever tested condition you have. So you have to have some kind of condition that gets tested. And so here they're going to check if the number of years is 50. So the equality operator, if we're going to check if two things are equal, that uses the double equals operator in Java. So if number of years is 50, great, we come in here. You can see that this is a code block. It has an open and close curly brace. And we get some output. Congrats on 50 years of marriage. And they get a hotel rate of half price. Fantastic. What if this is not true? Well, we completely skip this block of code. Okay, so if this is not true, if number of years is not 50, if it's 51, if it's 49, if it's anything other than 50, then we just continue on and you get the output right down here. So in addition to the equal sign, you might want to check if it's not equal to. So in Java, the not equal to is the exclamation in front of an equal sign. So this is read as not equals. Continuing on with some syntax. So what if you have two branches that need to be handled? So for instance, this code right here, we're going to get in a number. We're going to mod it by 2, so we're going to get the remainder. And so if the remainder is 0, that means it's an even number, right? If you can divide by 2, that means it's even. Otherwise, right down here, here's the path if it's not 0. So if you get any other kind of remainder, then that means the number has to be odd. And so you can see the if condition, again, wrapped in parentheses, open curly, close curly for that block of code, and then there's a separate else statement with its own curly braces right here. Oh, by the way, I would prefer if this else were up here on the same line, so it'd look more like this. Let's just go ahead and paste it into a text editor. I'll be right back. So let's just go ahead and paste that in here. And so again, my preference is that this would be on the same line right here. So bring that up onto the same line. Uh, do maintain the indentation. So if you're writing the code in the IDE, it will maintain the indentation for you. So we want to maintain the indentation for readability purposes. And always, always, always use the curly braces. And we'll talk more about that in a little bit. You could have a situation where you have multiple cases that need to be handled. So Java lets you have multiple tested conditions. So we have our first if statement. So some tested condition. If this is true, then these statements would execute. Keep in mind that once it finds a true case, it doesn't continue searching. So if the first condition is not true, it will then go look at the next tested condition and check to see if it's true. And you can have as many else if statements as you want. And then we could provide an else statement at the end. This is called the trailing else block, where this is going to catch any other cases where we didn't have a true case. Again, this is completely based on whatever problem you are solving. So if we come down here, they're going to take care of the anniversaries. So we get number of years. So that's a value that we've read in. We're going to check if it is 1. So if that is 1, then we're going to print out first year. Great. Otherwise, we'll check to see if it's 10. If that's the case, then we'll print out a whole decade. We'll check if it's 25, or we'll check if it's 50. And again, this right here, this is going to get every other case if we don't find one. So if we were to be 10, we would have executed this, and then we jump out of here and we continue with whatever comes after this decision structure right here. So again, will you have an else block for everything? Maybe, maybe not. It depends completely on the problem that you're solving. If you know that there is some kind of default value, then yeah, definitely have an else block. They do mention down here that comparing characters, strings, and floating types, the relational operator, those double equals, works for these integer, character, floating point built-in types. However, floating point types should not be compared using the double equal sign because of the impreciseness of how floating point numbers are represented. We'll talk later about how to actually handle those cases later on. And then with strings, you will not be able to use the double equals operator either. The only time that it works for strings is if they're the exact same reference, and we'll talk about that in a different section. Okay, so now they're going to kind of jump into some detecting ranges with branches. So a lot of the time we might have to handle certain things where we have to use less than operators. So for instance, we've got a sports team here that if you're under the age of 6, you don't get to play. However, there is a U8 team, which means your age has to be less than 8. There's a U10 team, your age is less than 10. There's a U12 team, which also means you have to be less than 12. So let's find our code examples. I think they're in the next section. Here we go. Let me go back. Hold on one second. We'll see an example here in a bit on the implementation. Uh, and it's in this section right here. So let's scroll down. So here we go. So if we want to check ranges, we can use less than operators. Or if we had to include a value, we could use the less than or equal to value. So here, we're going to check if the user age is less than 16. That means they can't drive, so we're going to create some insurance prices. So if they're less than 16, they can't drive, so insurance price is 0 and you can't be insured. Then they'll check if the age is less than 25, insurance rate's 4,800. If your age is under the age of 40, then your insurance is $2,350. And then again, remember, here's an else block that this is going to catch, as they point out here, everything where it's 40 and up. So the ranges, this is 15 and under. This right here handles the ages from 16 to less than 25, so 16 to 24. And then this range is from 25 to 39. And so here, this is for ages 40 and up. We don't need to put an else if greater than or equal to 40 here. We can just let the else catch this and handle all of those cases. Oh, by the way, it is imperative that your logic is correct. So in this case right here, in fact, I'm just going to copy this right here. So in this case, we have to have the logic correct. If we did something like this, so if we change the order, here, and I know it's kind of all sorts of disconnected, let's get this all fixed right. So if we change the order, so if we come in here and say user age less than 25, then that means anybody less than 25 is going to get this insurance price. So if user age equals 24, that would be correct, right? They're supposed to get that insurance price. But what if user age is 12? Remember, it comes in here and the first one that's true, it's going to execute. So yes, it would be less than 25. We would give a 12-year-old an insurance price of 4,800. We've created a logic error. It's not a syntax error. This would be a logic error. So you need to make sure that anytime you're dealing with some kind of numeric range, make sure that they go in order. You can't mix these up, okay? We can also use some logical operators, so we can combine tested conditions. And just like most programming languages, Java has the and or operator. There's also a not operator, but we already kind of saw that in place with the not equals. So the way that these work, if I am going to use a logical and, that means both conditions have to be true. So I have a tested condition A, I have a tested condition B, and so both of them have to be true in order for a true to result. If one or both of these is false, then it's not going to be true. The logical OR works when at least one of the tested conditions is true. So either A is true, B is true, or both of them could be true. And again, the not operator, we kind of saw it with equals. The not operator always negates the truthness. So it's always going to reverse it. So in Java, the AND operator is the double ampersand, the OR operator is the double pipe, and the not operator is the exclamation. Now, one thing to point out, if you have multiple tested conditions, so if I had something like this, so if I had A and B and C and D and so forth, the way that this works in Java is if any of these are false. So remember, all of these have to be true in order for the whole statement to be true. But if it finds one of them to be false, then it short circuits. It terminates checking immediately. So sometimes you might want to put your first check of things that catch all the cases. Might want to put that first, and then catch things as they go. Same thing is true for the logical OR. So I could have A or B or C or D. So I could have a list of things that I'm checking. Once it finds a true one, it's going to stop. It won't continue checking anymore. So here's an example that they use to represent TV channels. So we decipher this like here. So if the user channel is greater than or equal to 2, so if we're on channel 2 or higher, and user channel is less than or equal to 499. So that means we're between 2 and 499. If that's the case, then it is a standard definition channel. Otherwise, if the channel is greater than or equal to 1002 and it's less than or equal to 1499, then that's a high definition channel. So this would be very similar to mathematics. So back in your math classes, you would have written this out as such. Okay, so that means user channels between 2 and 499. This one right here, it's between 1002 and 1499. So again, this is how you would have represented it in math class. However, in programming, you can't write this. So if I try to write if and try to do something like this, you're going to get a syntax error. This is not valid syntax. You have to break it up into its parts. You have to check if user channel is greater than or equal to 2, and at the same time, it's less than or equal to 499. Oh, by the way, these parentheses that they use to enclose this tested condition right here, same thing right here. These parentheses are not mandatory. However, it does help in making the code a little bit more readable. So you can check to see, okay, this chunk is what's actually getting checked. And same thing here. This chunk is the second piece that's getting checked. Okay, next thing they have are what if there are gaps in ranges. So for instance, we're going to come down here and we're going to enter in an age. We're going to check the age. So if they're less than or equal to 12, then their movie ticket price is $11. Next thing they do is they check if user age is greater than or equal to 65. If that's the case, then they're a senior and they get a $12 movie ticket. Otherwise, their movie ticket price is 14. So when this says all their ages, what does that really mean? Well, we've got 12 and under taken care of. So we have ages 0 to 12, that's taken care of. And then we have 65 and above, those are taken care of. So what we have here is this would be 13 to 64, right? We have less than or equal to 12. We have 65 and above. So if you are between the ages of 13 and 64, then your ticket price is going to be $14. Again, you could represent this logic in multiple ways and end up with the same results. Here's an example that we're going to look at where we have separate if statements. So you might find a case where certain things are dependent on a single condition. So if your age is less than 16, we're going to say, hey, enjoy your early years. If you're greater than 15, right, you're old enough to drive. What if you're above the age of 17? Well, you're old enough to vote, right? And if your age is greater than 24, you're able to rent a car. And if you're older than 34, then you can run for president. Well, these are all separate, independent things. We wouldn't want to use an else if on these because that would make only one of these true. So this is a case where we would want to handle each and every one separately. And you can see here, if we put in an age of like 27, well, that means you are old enough to drive, you're old enough to vote, you're going to get a rental car, but you can't run for president. So we can see that's what would have been output there. However, if our age is 99, then we get all of these things right here. Some common branching errors, and I kind of alluded to it earlier. One thing is when you leave out missing braces. So if I take this code right here, I'm just going to copy it. So they didn't put curly braces enclosing this block. So this syntactically is fine because if there's no curly brace, then it will just simply execute the next line based on this condition. However, take a look down here. Remember I said it will execute the one single line. So here in this else, this is all that would execute. And every single time, this would always execute for everybody. So the fix is always, always, always use curly braces. So as soon as you write out the code, put an open and close curly brace, and it will prevent any kind of potential logic error in here. And if you want to have more statements added, you'd have to add these in anyway. So just go ahead and do that every single time. They point out here that using the equal sign instead of the double equals, you're going to get a compiler error, so you have to use the double equal symbol. Next section, they talk about switch statements. So in Java, the idea of a switch statement is we're going to look at a particular case and handle each of them separately. So it's really just like an if-else-if structure where we have a case where the value is 0, we have the case where the value is 1, we have a case where the value is 2, and then this is just like our else block. So the syntax goes switch, you have some kind of case, some kind of value that we're looking at, and then based on that value, what are the possible cases we want to handle? After each case is handled, each one requires a break statement. So if there isn't a break statement, we actually fall through and we would continue executing until we find an actual break statement or we get out of this switch statement. So that's always a issue that new programmers forget is you forget to put in that break statement. So again, we could have an if else if statement. And again, it can just be represented as a switch statement. It's the exact same kind of idea. And again, they just mentioned down here that if you don't put the break statement in, then it's called falling through. And we go until we find a break statement. And in some cases, we might want it to fall through. So for instance, if we've got some dog ages, when the dog age in months is 0, 1, or 2, we want to handle all three of those cases the exact same way. For cases 3 through 6, again, you can see there's no individual statement for each of these. We're just going to handle all of them the exact same way. Oh, by the way, the switch statement in all the projects I've been on in industry, we just avoid using switches and case statements. So it's something to be familiar with, but in all likelihood, you're probably not going to see it in industry because we usually don't use that in our code standards. Next thing that to introduce here is that we can use a Boolean variable as our tested condition. So they come in here and they're going to declare a Boolean called is large party, a Boolean for if it is the weekend. And so they check if the day is Friday, Saturday, or Sunday. If that's the case, it's the weekend. Otherwise, it's not. They check if a large party, so they check if the party size is greater than 6. If that's the case, then that would be true. Otherwise, it would be false. And that we can use these Boolean variables in our tested conditions. Because remember, these return a true or false. So this is if it is the weekend and it's not a large party. So we can kind of make our code really readable here. Then we have a wait time of 30 minutes. If it's not the weekend, if it's not a large party, then you're only going to be waiting 10 minutes. So we can make the code nice and readable here using some Boolean variables. And we don't have to have the checks multiple times of, day, Friday, Saturday, or Sunday, each and every time we look for the weekend. Next thing, so string equality. So checking if two strings are equal. So in Java, you do not use the double equal sign to check if strings are equal. This is going to apply for anything that is not a primitive data type. So the only time you'll use the double equals is if you're using an int, a um, long, any of the primitive types, you can use the equals operator to check if they are equal. And again, oh, by the way, with doubles and floats, because of their preciseness, we want to avoid using the double equals for those as well. Back to strings. So if we want to check if two strings are equal, you use the equals method on a string. So you can see down here, they come in, they read in a user word. So right here, user word has been assigned some kind of text, and it is an object. So strings are objects in Java. They have methods that let you interact with the data. And so all objects have an equals method. So you can go dot equals, and then you provide it the text that you want to compare against. So this checks if these two strings are equal. If you use the double equals on the strings, it's going to check if they are the same reference. And in this case, they would not be the same reference. We have two different things. This is a variable. This is a string literal. Their reference is not going to be the same. If I did something like this, you would not do this, but if you were, string user word equals USA, string another one equals USA. Behind the scenes, Java is going to only create one instance of this on the heap. And if I did if user word equals another word, that would actually come back as true. An even easier way to understand this is if I did this. I am just simply copying the reference. They point to the same thing. These are going to be true. But we never, ever, ever use the double equals with strings or primitive types. You always use the dot equals method. So again, always use the dot equals method for strings and non-primitive types. In this section, they talk about what's called a conditional expression or a ternary operator. Um, this conditional expression is the exact same as an if-else block. You have some tested condition, and you handle the true case, and then you handle the not true case. So in Java, the ternary operator is the question mark. So you have some kind of condition that's being checked. And then after the question is the result when true, and then there's a colon. This would be the result when false. So they have an example right here where we're going to assign y. They're going to check if x is 2. If that's the case, it's going to spit back 5. Otherwise, the result is 9 times x. So this is the value when it's true. This is the value when it is false. And here's a nice little example. They're showing right here that if the number is greater than 1, it's going to return a 9. Otherwise, it returns a 4. So all this does is it takes an if-else block. I'll just come right up to here. All it does is takes this if-else blocks and turns it into one line of code. Oh, by the way, don't nest ternary operators within ternary operators. It's totally possible that you can do that. However, it makes the code more difficult to read. And then the last section we'll look at here is talking about floating point comparisons. Again, you can use the double equals, but you are not guaranteed that it's going to be accurate because of the impreciseness of how floating numbers are represented in computer memory. So what you have to do is you have to use some kind of tolerance, or they're going to call it an epsilon. So how close do we need our value to be? This is what, tenths, hundredths, thousandths, 10,000. So this is saying if you're within 1/10,000th, then we're saying they are equal. They're close enough. So they implement that down here. They take a body temperature. When you subtract it from 98.6, if that tolerance is less than here, then you are a normal body temperature. Again, they could not have checked if it was equal to 98.6 because you're not guaranteed the precision that it's going to represent exactly 98.6. One of those values, so for instance, body temp, it could actually be 98.5, 99999, like that. So you're never going to get exactly 98.6 when it gets represented. So you use a tolerance for that. There's also other data types. So for instance, a big decimal data type, it's an object that you can use to handle better precisions. Okay, that's going to wrap it up for this recording. Again, the main idea to get out of this is, can you structure your logic, making sure that it is correct? If the logic isn't correct, it doesn't matter what you type here, you're going to have a problem. So make sure that you understand what you're trying to do, implement the logic properly, and then make sure that you test it. All right, we'll talk to you next time.